This is a pretty tough question on principle of moments because it requires you to apply what you have learned in trigonometry and Pythagoras theorem. So once you see the method, the way to solve this question becomes very simple. So let's go through this together. And over here you have a wheel or barrel, and someone is pushing the barrel towards the left, as shown by this force over here, and this will ultimately make the barrel roll up the step. So you are to find what is this value of the force F, the pushing force F, that is required to just shift the barrel up the step. So as per all moments question, it is critical that we determine where the pivot point is. So when the barrel is just about to roll out the step, the whole barrel will rotate about the pivot point in green. So I put in the pivot point in green in the slide. And as per usual, we look at what are the forces acting on this object to determine the type of rotation. So if weight is the only force acting on the barrel, then it will want to make the barrel rotate in a clockwise manner about the pivot point. If force, so before that, this will be the perpendicular distance in yellow. So again, if you need help with identifying the perpendicular distance, look for earlier video in the MCQ. For the pushing force F, if that is the only force acting on the object, it will want to make the barrel rotate in an anti-clockwise manner about the pivot. Again, the perpendicular distance is the vertical distance. If you need help with that, refer to the earlier video. So right now, before you plug this into a POM equation, we can try to figure out what is the distance, perpendicular distance for to tag with the pushing force F, which is the red color perpendicular distance. The perpendicular distance can be solved using Pythagoras theorem. I hope you see a right angle triangle, and right angle triangle, if you know two sides, you can use Pythagoras theorem to figure out the third side, which is 0.30 meters. Of course, in this question, actually there's a faster way to get 0.30 meters as the red color vertical distance. You can simply just use 0.5 meters over here, minus away the 0.2 meters to get the balance, 0.3 meters. But I thought I will show you Pythagoras theorem because it will be a very handy trick to use to figure out any sides of this right angle triangle, should any of these values be missing in the question. Okay, so Pythagoras theorem can be used. And in this scenario, notice that I have not mentioned about this normal contact force by floor on barrel. By right, if you look at my laser pointer, that should be a normal contact force by the floor acting upwards on the barrel that supports the barrel because the barrel is on the floor. In this scenario, I'm saying that this normal contact force is 0 newtons. It's not that. Simply because it is at the verge of rolling up the step. That is what the question is asking. Calculate the smallest value of F to cause the barrel to roll out the step. So on the verge of rolling up, the floor is no longer supporting the barrel anymore. Hence, the normal contact force is 0 newtons. So what remains to be done is to plug in the two moments into POM equation. I plug it in. I've color coded it for you to check answer, and with that we can get the force to be 4,000 newtons.